Well, good day once more. This is Professor Friday coming at you. We are going to be doing a little bit of trigonometry today. This is going to be a really good quiz or test type question. Wink. So, we are given the value of one of our trigonometric ratios, and we are told one additional piece of information about the angle. We're asked to find all 6 trigonometric ratios of the angle theta. So first thing I'm going to do, this is the first thing that I did on the last one as well. I want to copy down the greatest acronym that has ever existed in the world of trigonometry, which is SOHCAHTOA, to remind us of what sine and cosine and tangent are. Now, the piece of information given to us in the problem is that the cosecant is equal to 8/5. Well, given that the cosecant of theta is equal to 8/5, that doesn't really tell me a whole lot of information. I enjoy the big three: sine, cosine, and tangent. Thankfully, we have a reciprocal identity that we can apply here, which is that the sine of theta is the reciprocal of the cosecant of theta, which in this case would be equal to 5/8. So that is going to be an important piece of information. That is about the worst box I've ever drawn, but whatever, it's fine. So in addition to this piece of information, we are also told that the cotangent of theta is a negative value. Now, again, cotangent isn't one of the big three, but thankfully, the tangent is the reciprocal of the cotangent, which tells us that if the cotangent is negative, that means that the tangent is also negative. So the question that we get to pose to ourselves is, if the sine is positive and the tangent is negative, what quadrant is our angle theta in? And I write down ASTC for all students take calculus to remind us of what is positive in what quadrant. In 1, they're all positive, 2 is just sine, 3 is just tangent, and 4 is cosine. So first off, we know that the sine is a positive value. If the sine is positive, that means it's got to be in either quadrant 1 or 2, which means that we can eliminate 3 and 4 as possibilities. In addition, we have that the tangent is negative. As soon as anything is negative, we can immediately get rid of quadrant 1, which means that the only possibility is that theta is a quadrant 2 angle. Quadrant 2. So the way I'm going to start drawing this angle is, here's my Cartesian plane. I'm going to start with generic quadrant 2 angle theta. In addition, since we're going to be calculating some trigonometric ratios, I'm going to draw in a reference triangle by dropping down a perpendicular to the x-axis line segment. Now, the other thing to figure out is associated with this angle, what are the values of A, B, and R? Or we would have called those the adjacent side, the opposite side, and the hypotenuse on a regular old right triangle. Now, we have that the sine of theta is equal to 5/8, and the sine is the opposite over the hypotenuse. In terms of our reference triangle, what that gives us is the opposite side, which is 5, and the hypotenuse, which is 8. In terms of A, B, and R, what we're looking at is that the B is 5 and the R is 8. So if you have two sides of your reference triangle, how do we figure out the third? And my students are always really good at answering that question. They always say, Pythagorean Theorem, and I say, that's absolutely right. So the relationship that we have here is that a squared plus b squared is equal to r squared. Now we have a value for b, and we have a value for r, and we're going to solve for the value of a. So something to keep in mind is that we are in quadrant 2, and the x-coordinate is negative in quadrant 2. So when we solve for a, we're going to have the option of doing the positive square root or doing the negative square root. When that happens, we're going to take the negative square root. Solving for a squared, we're going to subtract 25 from both sides. We get a squared is equal to 39. Now here's where that really important thing comes into play. We're in quadrant 2, so when I take the square root of both sides, a is going to be a negative value. So we get a is equal to negative square root of 39. Now, we're going to see that square root of 39 in a lot of denominators. We don't have to rationalize the denominator because I'm super cool. I don't require you to do that. But some teachers might require you to do that, so we're going to rationalize our denominators just to be safe. Once you have the values of a, b, and r, you can calculate what all 6 of these trigonometric ratios are. And we're going to start with my favorite, the big 3. Sine of theta. Well, we were actually given the sine of theta, well, the cosecant of theta in the problem, so we calculated the sine of theta without too much difficulty. But really, the sine of theta is equal to b over r. b over r we calculated to be 5/8. The cosine of theta, that's the of SOHCAHTOA, TOA, that's the adjacent over the hypotenuse, or in the unit circle trigonometry, that's a over r, or excuse me, just circle trigonometry. That's going to be negative square root of 39 over 8. And the tangent is going to be equal to b over a, or opposite over adjacent. That's going to be 5 over negative square root of 39. Now, if we were to rationalize this, then this ratio would look like negative 5 times the square root of 39 over 39 by multiplying top and bottom by square root of 39. But again, I'm not going to require you to do this, but if you want to, that's fine. Now I'm going to take some reciprocals. The cotangent of theta is the reciprocal of the tangent of theta. We said that the tangent of theta was 5 over negative square root of 39. I'm going to go ahead and flip that so I don't have to re-rationalize the denominator. That's negative square root of 39 over 5. Then the secant of theta is going to be the reciprocal of the cosine. Using our reciprocal identities, that's going to be negative 8 over the square root of 39, which again, you can rationalize if you totally want to. And then finally, the cosecant of theta is going to be the reciprocal of the sine. But again, this value was given to us in the problem, so it's not even necessary to do that much. And we'll just put in a little boundary between these. So put it all together. Here are your 6 trigonometric ratios of the angle theta. So once again, really important part of the process. Use the given ratio and the given information to figure out what quadrant does the angle theta lie in. Then we draw a generic angle in that quadrant and then label 2 of the sides. We get 2 of the sides from the one ratio that's given to us. That's got to give us either a and b, or a and r, or b and r. In this case, it gave us b and r. Then use those 2 sides to calculate the third side. The third side, whether it's positive or negative, is going to depend on what quadrant we're in. Keep in mind, though, r is always positive. R refers to a distance. A and b, those are your x-coordinate and y-coordinate, respectively. Those can be positive or negative. We were in quadrant 2, which has a negative x-coordinate, so when we calculated our a value, it was negative. Once you have a, b, and r, calculating your 6 trigonometric ratios is simply a matter of do you know the formulas? So I hope this was of assistance to you, and I'll see you for the next tutorial.